This topic takes another topic a step further. If you looked at the video or you've learned how to do solving systems, excuse me, of equations with elimination, this one takes it a step further. So if you haven't learned how to do just plain old elimination, go back and look at that video. I also suggest you look at the video that just says Intro to Systems of Equations, because that gives you a good general idea of what the heck you're doing or why you're doing things. Alright, so for this one I'm just going to start with an example and kind of assume that you've looked at the other topics. So let's say we have 2x minus 3y equals negative 8. And for our second equation, again, a system of equations is just more than 1 plus 5y, and that's going to equal negative 1. In elimination, what you've seen before is generally we look at the x values and they are the same, and we either add or subtract the equations together, or we look at the y values and the same thing could happen. When we look at our x's here, we have a 2x and an 11x. There's no way they're going to just go away. And for the y's, we have a 3 and a 5, and there's no way they're going to go away just by simple adding and subtracting. So what we're going to do is we're going to force these equations to behave the way we want to do them. So in this case, we have a choice of eliminating y's or x's. Since I'm running this video, I'm going to choose x's just because I want to. And what I'm going to try to do is I'm going to make it so that both of these are 22's in front. So if I look at the top equation, what do I have to multiply 2x by to make it be 22? I have to multiply by 11. Now to do that legally in algebra, I can't just go and multiply the 2x by 11. I have to multiply every single term in that equation by 11. That will keep it legal. So let's do that. 11 times 2x, that gives us 22x, minus 3y times 11 is 33y, equals, don't forget that negative 8 times 11. Got to do it. Now I'm going to look at the bottom equation, and I have an 11x there. What do I multiply the 11x by to make it be 22x? I have to multiply everything by 2. So again, 11 times 2, 22x, plus 5y times 2 gives me 10y, equals negative 1 times 2 is negative 2. Now I got it so that my 22's are lined up. They both have the same number in front of the x's. As I said, they're the same sign, so I need to subtract. 22x minus 22x, they're eliminated. That's exactly what I wanted to have happen. For my y's, I have a negative 33y, I like to write it sideways, minus 10y. Well, that's going to give me a negative 43y. And now I have, for my numbers, again, I'm writing it sideways so I can process these negative signs. I have a negative 88 minus a negative 2. Aha. Boop, boop. So it's now actually negative 88 plus 2, which is going to give me 86. Now I just have to solve this for y. To solve for y, I divide through on both sides by negative 43. And just, they cancel out on this side. A negative divided by a negative is going to give us a positive, and 86 divided by 43 is 2. So we have our y value. Now, as you've learned about systems of equations, when you have a solution, there's an x value and a y value. We found the y, so we go back and take any of the equations that we have and plug in 2 for y. I'm going to choose the 11x one just because I feel like it. So I have 11x plus 5y equals negative 1. I know that y is 2, so 11x plus 5 times 2 equals negative 1. 11x plus 10 equals negative 1. Subtract a 10. And now I have 11x equals negative 11, so x equals negative 1. So my solution for this, where they crisscross, is at negative 1, negative 11. So the gist of it is that you're doing exactly the same thing as the elimination process, but we're manipulating the equations first before we get started. Alright, let's try another example. And just by the way, just in case you're one of those trivia buffs, in the old days, or like the old textbooks, they called this not just elimination, but they called it the linear combination method. So in case you hear that bantered around, that's where it comes from. Alright, let's try 3x plus 5y equals 17. And let's see, 2x plus 3y equals 11. Again, we're set up with the same thing. Our x's have different numbers called coefficients. The y's have different numbers, also called coefficients. This time, just because I did the x's last time, I'm going to make the y's disappear this time. So what number is common to 3 and 5? Well, I can turn them both into 15s. So the top equation is going to get multiplied by a 3, and the bottom equation is going to get multiplied by a 5. So now I want to rewrite these guys. 3 times 3x, 9x. 3 times 5y, there's the 15y I was talking about. Oh, 17 times 3, that's one of my favorite multiplication ones. That's 51. I love that product. Sorry, I know it's corny, but I do. And now the bottom equation, 5 times 2x, that's 10x, plus 5 times 3y is 15y, equals 5 times 11 is 55. Need to decide whether I'm adding or subtracting these y's together. Both of the 15s in front of the y are positive. They have the same sign, so I subtract. 9 take away 10 is a -1. 15 take away 15 goes away. And 51 take away 55 is -4. I need to get rid of that -1 in front of the x, so I divide. So x is going to end up being a +4. I need a y value because every solution to a system is an ordered pair. So I will choose this top equation, 3x plus 5y equals 17. My x is 4, so now I plug that in. And then I just solve for y. 3 times 4 is 12. Here we end up with your basic two-step algebraic equation to solve. You need to get rid of the 12. To bring it to the other side, you subtract. Do it to both sides of the equation. 5y equals 5. And then to get rid of the 5, you need to divide both sides. So y equals 1. So our answer, where do these two lines crisscross? They crisscross at 4, 1. There you go. Alright, let's try another example. This one would be a good one for you if you feel comfortable enough copying down the problem, hitting pause, solving it out, and then hitting play. I will give you a little warning. This one's going to do something a little bit funny, but if you've watched my video about the intro to systems of equations, you probably catch it. Alright, so let's say that we have one equation. We'll say that it's 2x plus 7y equals 3, and then let's say that we have 6x plus 21y equals 9. Alright, so if you want to try hitting pause and solving it on your own, go for it. I am going to look at my x's. Notice that 2 goes into 6. This can make it easier, so I only have to, this is the only way to do this problem, but if I want, I can just take the top equation and multiply by 3. I don't have to do it that way. I could make both of them be like a 12 if I wanted, and that's a-okay. But I'm just going to do it kind of my own way that this will still work out. So if I multiply everything on the top equation by 3, 3 times 2x gives me 6x. 3 times 7y gives me 21y. And 3 times 3 gives me 9. Now I can just copy the bottom equation exactly the way it was. And I don't know if you're paying attention or not, but you might have already noticed something. So my x's are both 6's. They're both positives. So I have the same sign. I'm going to subtract. 6x minus 6x goes away. 21y minus 21y. Ooh, that goes away also. And looky here, 9 minus 9 gives me 0. So yes, it feels really strange. Did I do something wrong? Absolutely not. My x's and y's both went away, so all my variables disappeared. I ended up with 0 equals 0. Well, if you watched my intro to systems equation video, you learned that if you end up with all your x's and y's disappearing, and you end up with a true statement, because 0 does equal 0, then you know that, in fact, we actually had the same line. 2x plus 7y equals 3 is exactly the same line as 6x plus 21y equals 9. And when you rewrote both of them, you might have noticed that. If you caught yourself writing 6x plus 21y equals 9 twice, it might have dawned on you then, like, hey, these are exactly the same equation. So if you graph one equation and put the same equation on top of it, you have an infinite number of solutions. Because a line on top of a line lines up perfectly. So we have an infinite number of solutions. You obviously don't have to list them all out because that would just be silly. It would never be done on that problem. So, alright, I hope that worked out for you. And let's just do one more example, just since that one was a weird, like an oddball one. I want to do one more that comes out with an actual answer. Alright, one more. Last problem for this type. And again, I would suggest that you try to do it all on your own. Hit the pause button once you got it written out. Let's try 4x plus y equals 42. And our second equation is 6x minus 5y equals 50. Alright, so hit that pause button. So again, you have the choice. Do you want your x's to be the same number? You could either make them both be 12 or both be 24, whatever you want. Or you can make the y's both be the same number, and that's the one I'm going to go with because that's going to be a lot easier. I only have to multiply the top equation by 5, and I can leave the bottom equation exactly as it is. Alright, so when I multiply everything through by 5, I'm going to get 20x plus 5y equals 210. My bottom equation I can just rewrite as it is, 6x minus 5y. That doesn't really look like a y. Let me clean that up. So 6x minus 5y equals 50. Alright, so my y's have the same number. They don't have the same sign, so I'm not going to subtract. I have a positive 5 and a negative 5. I'm going to add them. So 20 plus 6 gives me 26x. 5 plus negative 5 is gone. 210 plus 50 gives me 260. Now all I need to do is solve for x. The 26 is multiplying, so we're going to divide. And this one comes out pretty nice. X is just going to be 10. We need to find our y value now. So I will take the top one, 4x plus y equals 42. I know my x value is 10, so it's 4 times 10 plus y equals 42. 4 times 10 gives me 40. And let's see, so now to solve for y, I just need to fix my little mistake there. That's 42, not 40. 40 plus y equals 42. I need to subtract both sides or 40 from both sides. That's going to give me 2, and I get y equals 2. So my ordered pair is these two lines crisscross at 10, 2. There you go. If you have any questions, come find me and I'll see if I can clarify. Thanks.